Hello.
Hello, welcome everyone to Virtual Starry Nights. You are joined tonight by myself, Matthew Simone, and of course my co-host. Want to introduce yourself?
Zena. So
Hell,
excited.
so excited. So we are coming at you live, but kind of not live from the observatory, and that is because we're actually not there right now. We're controlling our cool observatory remotely. This is one of the cool things that our observatory is capable of doing. And that way we're actually able to dial in at times when we couldn't be there. I know that a lot of our virtual population and fan base, we actually formed during the pandemic, for example, when we all couldn't necessarily be at the observatory. And so for those of you who might be out in that direction ever during the weeks, thank you for visiting us in person. And we hope that you are now visiting us remotely. And the weather's been great. Zena, did you get any of the cool sun today? Were you out in the sun?
Absolutely. I've been really enjoying the weather. But before we go, let's introduce our moderators. So our
Yeah.
moderators are Zach and Malcolm. Hello, hello. So they're going to be the one who's going to answer any questions you have. Any burning questions about space and astronomy?
We will be
But yeah.
happy to answer, and they will be too. So all of us. So we figured we get things started right now. If you happen to be outside, you might notice that out into the west, toward the horizon, not quite all the way down there, but there's one very, very bright star in the sky, and that is, in fact, Jupiter. And guess what? We are looking at Jupiter right now through our camera. So we're actually pointed at Jupiter at the moment, but I've got the exposure turned down on our camera. So if I bring it up a little bit, we'll begin to see. There it is. There is Jupiter, the gas giant planet, most massive planet in the solar system. Right now, you can see the stripes on the planet of Jupiter there on the stream. And cool thing about Jupiter, way back in the day, there was a person named Galileo, one of the first to study the night sky with a telescope, and was looking up and saw these moons, the 4 points of light moving around the planet. And that was some of the early evidence that we had that Copernicus, who beforehand had said probably Earth is not at the center of the solar system, but in fact the sun, and was right because we were seeing moons that were in fact orbiting around Jupiter as well, and or Galileo saw them. That's why they are called the Galilean moons. So if I turn the brightness up a little bit more, we'll start to see them coming into view. And we can
I like
see,
how Jupiter can be its own solar system.
right? Yeah. And so we know that there are dozens and dozens of moons around Jupiter. We keep finding more all the time. It's funny because in my other role, when I'm working at the planetarium, I bump into a lot of kids, and they all are excitedly want to share with you how many moons that they know Jupiter have. But the number changes so frequently that it like almost,
Yeah.
so often they're like, I know there's 70 some odd moons. And they're like, oh, we're up to like 90 now or whatever. But these are the ones that you could see easily through even like a half decent telescope, binoculars, or even like a DSLR camera lens. Right now, actually, right before we started the stream, we were able to see all 4 of the Galilean moons. Io, though, however, has now passed either right in front or behind Jupiter, so we're not able to see it currently. What are the other ones? Well, if you ever wanted to know when you're looking at Jupiter, I can bring up here. I've got a page open. Oh,
That's insane. Jupiter has now, you said 90 moons? That's
yeah, I think
insane.
it might even be more than that right
Last
now.
time when I was teaching, I think it was in the 80s but now we got to the 90s. That's amazing.
Yeah, we keep finding more of them all the time. And also, one of the reasons why is that we have a probe that's dancing around Jupiter right now called Juno, and taking images and pictures and that kind of thing. And also, we're discovering more with our telescopes all the way from planet Earth. But if you want to know, all I did was I Googled this. This is a cool website. It's called theskylive.com, and it can tell you things about like what's in the sky, the current configuration of the solar system, or right now, the Jupiter system. So the moons that we are looking at, again, we have Io very close to Jupiter. Over here we have Callisto, Europa, and Ganymede. We are looking at this image mirrored through the telescope, so it's kind of reversed. So if we flip it back to here, we have Europa here. And this one here in particular, we are really interested in because that moon might have an ocean, or like we know it has an ocean, but we're hoping that in that moon it might have life. What do you think might be down there? Space fish?
Who knows? Some
space
very
turtles.
cool alien
Wouldn't
microorganisms.
that be neat? Yeah. So we've got the largest probe ever
Or a
created.
mermaid. Is that what we're gonna call them?
Space
Mermaid,
mermaids.
merman.
Yeah, space sirens. So yeah, the largest probe that we've ever built right now is on its way to Europa. It's called the Europa Clipper, and it's supposed to arrive in 2030. It's one of these probes that's helping to figure out whether or not it's possible to detect signs of life under the icy surface of this moon. So the ice on the surface of Europa could be up to 10 kilometers thick, and beneath that is twice the water volume of the entire planet Earth, which is astonishing to think about, that there's these floating oceans out around Jupiter and Saturn. But while we have Jupiter here, I wanted to talk quickly. Some of you might have heard in the news recently that we have had a place in space where people have been talking about a lot that might have life. And it is a planet called K2-18b. So I'm going to see, I saved a picture of it here somewhere to the desktop, so I'll bring that up. And K2-18b, that planet, here it is. And so this is an artist rendition. We don't actually know what the planet really looks like, but this is an artist rendition of it. I brought it up because it was suspected that this planet, which is 124 light years away from Earth, it is orbiting the star, which is a red dwarf star, so much about half the size of our sun. And it is called K2-18. So it has that name because it was discovered by the second set of Kepler telescope mission. Kepler was a planet hunting telescope. This is the 18th star that it was observing, and this was the first planet to be found around that star, which is why it's called K2-18, and then B. The star gets the letter A, B goes to the first planet. And now, what had happened is several years ago, the Hubble Space Telescope detected what it thought might be water vapor in the atmosphere of this planet, and we were excited about that because we thought that maybe it meant that because this is a habitable zone planet around this star, it has the right temperature where it's not too hot or too cold, that it might have an ocean. And then later on, we started discovering, or we thought we discovered with the Webb telescope, that it was possible there was a chemical in this atmosphere called dimethyl sulfide. And on Earth, dimethyl sulfide primarily comes from phytoplankton and bacteria in the ocean. Now, that is exciting because that could potentially mean that this is a biosignature around this planet. And so there was a lot of hype in the news last week, and I think the week before as well, because there was a team at Cambridge that at university, I believe, that had said that, you know, they kind of doubled down that yes, this chemical is in the atmosphere. Now, since that time, however, we've been a little bit more hesitant. There's been a couple other groups that have come out and said that may not actually be the case. And the detection threshold, or the quality of the detection of that chemical in this atmosphere, may not be as high as we thought. And instead of being an ocean planet with like a water vapor hydrogen atmosphere, it might actually be more of like a Neptune type planet that doesn't have any of this dimethyl sulfide at all. But this is how we're doing this search for life out there in the universe. This planet way too far away than we could ever reach in our lifetime, of course. It's 124 light years away, but we can study it from a distance with our telescopes and see from the chemical signature in the atmosphere, just from the light of the atmosphere, whether or not anything is alive there. So in the meantime, the only alien ocean we're going to be, I think, studying right now that we know of in our solar system, of course, is going to be this one that we're headed to here. But also possibly we'll find a distant one in the future as our telescopes continue to improve. So some exciting things.
Maybe there are life and they're looking at us. It's just the time.
I want to hope that, I want to hope that maybe out there in the universe, maybe there's some people looking back in our direction as well. Wouldn't that be cool?
Yeah, and then there's I was just thinking when you were saying that, because we can't really reach it, we can't travel there. And I was thinking about the universe expansion. I was like, oh, and the distance will just get larger and larger.
Yeah, that's the other thing, right? Things are always getting farther and farther apart. Within our own galaxy, it's going to kind of stay fairly put. But yeah, I mean, there will be a time in the future where even people in the Milky Way, or life in the Milky Way, won't be able to see other galaxies. I know there's another planet we wanted to talk about that you want to talk about, Zena. Should we move on to Mars? Is that what we want to do?
Oh, absolutely.
All right,
sure. We can. Yeah, let's change gear to Mars. Absolutely. Mars, a red planet. So in comparison to Jupiter, Jupiter being one of the largest planets in our solar system, Mars is it's actually the fourth planet from the sun, and it's also considered the second smallest in our solar system. It's the one that we all maybe had dreams about colonizing, the planet, like, or living on another planet. And all like some really cool facts about and more cool facts about Mars is that I thought it was very cool is that Mars, that just the month Jupiter, sorry, the month March is named after Mars. So that's very cool. Cool thing. Like I always associate March with Mars, and it's also the god that it's the Roman. It's named after the Roman god of war, which we all know that. In terms of how far away it is, it's about 228 million kilometers away from Earth. But one of the most fascinating thing about Mars that I like that I like to share with people is the sunsets. So we know that with Mars, they have pink skies or red skies in comparison to Earth. We have more of the bluish skies. And but then when it comes to sunsets, it's kind of the other way around. So on Earth we see red, orange sunsets or yellowish sunsets, but on Mars you actually get to see blue sunsets. So I was like, oh, well, that's actually very, very a very nice view.
Is
Just
that
a very
wild?
nice view.
That's wild.
Mhm.
Actually, that and sort of there's a question that came up here from in one of the questions from Snooze here on YouTube, and they asked with Kepler planets or any planets, how do we know that there might be chemicals present in the atmosphere? And just so you're talking, just like you were talking about here, Zena, about how say the sky or the color of the sky might look different on a different world. A lot of that is because of the starlight passing through the atmosphere, and it changes the color of that sunlight. Just like we see on planet Earth, we see that the sunlight changes as it passes through our own atmosphere. So whether you're here on Mars or on Kepler K2-18b, your atmosphere has a different color, and we can literally tell what the chemical composition of the atmosphere is because of that. I want to see a blue sunset on Mars.
Yeah, me too. It's like I'm surprised there's not as many photos that I expected to see. But I think there is maybe one image out there of that shows like the blue sunset on Mars. But yeah, it's kind of it's very fascinating that like you have like the blue light and the red light. So on Earth, the blue light is the one that gets scattered into our skies, and then when during sunset, then the red light is the one that passes through and reaches our eyes. So that's why we see it as red. But on Mars, it's the complete opposite. You have the red the red light is the one that gets scattered into the sky, and then the blue light is the one that passes through. And that's how we would, if we were there, we would see it. We would see the blue sunsets. So I just find that super, super fascinating.
Yeah, super cool. Recent discoveries on Mars. I know our view of it here is a wee bit fuzzy. I think we got some atmospheric turbulence going on right now. But by the way, if you happen to be on the stream right now and you just take a quick look outside, I don't know if you have headsets on or you happen to be outdoors. If you look kind of straight up in the sky, Mars is the brightest red point in the sky right now. So you can actually see Mars at this moment, like straight above us. But cool thing recently, there's this probe on Mars called InSight. I can actually bring up a picture of the InSight probe. It's cool. Kind of think of like probe Mars. Think of it kind of like in terms of almost like an ultrasound. So we've got this probe on the surface of Mars, and what it can do, here's a picture of it here, is it's actually listening to Mars, kind of in a way. You can think of it like that. It's feeling vibrations in the surface, and through them, it is able to hear kind of what's going on inside of the planet. So when things happen, like if there are Mars quakes or say an asteroid strikes Mars and sound waves are traveling through the planet, this probe is able to determine, it has an InSight, which is why it's called InSight. There's an acronym for it. Don't remember, ask me what it is off the top of my head anymore. But what happens is as those waves are passing through the planet, it gives us a sense of what's inside of Mars. The rover here, these solar panels are large enough that you can kind of lay across it. They're almost 6 feet across each. So it is quite a large probe. But one of the things we discovered is that probably 15 to 20 kilometers underneath the Martian surface, it looks like there's oceans worth of water still down underneath Mars. So that's exciting because it's possible that that might be a habitable region deep underneath Mars, which would be really cool because maybe there's something still living underneath Mars if there ever was, deep down underneath the surface.
Yeah, exactly. That was going to be the other point I was going to bring up is that how it's similar to Europa for Jupiter is that Mars has the ice cap. We used to be able to see or kind of visualize the ice cap with our telescope, but I guess it's hard to see it right now. It just looks like a red or orange planet. I know there are times where people were able to see our the ice, kind of slightly see it, and they see like a little ice cap in the north.
Yeah, it could be
But otherwise,
could be a couple things
oh
going
yeah,
on.
sorry, go ahead.
I know we're not as close to Mars as we were even like a few months ago. So that could be part of
Yeah.
it. Sometimes there's atmospheric disturbance on Mars. I know we're getting some atmospheric turbulence right now. I'm like we can see Mars kind of going in and out of focus. But sometimes Mars is really dusty. There are like dust storms on Mars that can sometimes cover the whole planet. So, but yeah, you are right though. I do remember times when we have been able to make out that white polar ice cap on Mars.
It's yeah, yeah. Oh well. Yeah, actually, it's like you mentioned. So Mars is very dusty, and it's kind of it's actually like the maybe another reason why it's reddish because it's rich in iron. Like it has a lot of iron, carbon dioxide.
Mm-hmm.
I guess it has that reddish signature to it. So that's why like it gives that red. It gives that a color red to the planet, and hence red skies or pink skies
Yeah,
at the
totally.
end.
Yeah, I don't know if any of us will ever make it there one day. I know, like we've been talking about putting people on Mars for a long time. I get asked a lot by young people in particular if whether or not that is part of a mission to like resettle the population of our planet, and I don't think that that is the case. I think it's really cool that, or it should be one of our goals. I don't think either. I mean, I think it's really neat that one day we might have people doing science there and maybe looking for another branch of life even within our own solar
Hmm.
system. But when people ask if we can, like, if we could make Mars more like Earth, so that we have like another place to live, then I usually want to say, well, if we can make Mars like Earth, then maybe we can keep Earth like Earth. And then
Exactly. Yes.
we don't have to go somewhere else that way at all. But yeah, Mars is going to be a really tough place to live. It is the average temperature on the planet minus 80 degrees Celsius, and I think, like you mentioned, less than 1% of Earth's atmosphere. So difficult
Yeah.
place. But I would still love one day for someone to make it there. Maybe it's someone who's been in one of our live streams that could send us a postcard.
Exactly. Yeah, actually, it's I don't know if you ever heard. This is a bit kind of separate from Mars, but I've heard yeah, I don't know if you heard that you can actually buy land on Moon. I thought that was Moon doesn't have an atmosphere as well, and even its gravitational force is very different from Earth. It's
I
almost like
wonder if
16.
that'll be honored. Do you think that would actually be valid if anyone gets out there? I feel like maybe someone just made up a
I mean,
really
I
like
was gifted.
smart
Someone gifted
gift.
me
Yeah,
land.
land on
I
the
don't know
moon.
how many acres it was. It was a lot of acres on the moon. So I thought, oh wow, okay, just in case the house, since the house market is crashing here in Vancouver, okay, I have some equity on moon.
Yeah. We
So
might.
that's kind of
We're gonna start a
that's,
commune up there with
that was
you.
my thought about Mars. Maybe that's gonna happen to Mars
Yeah,
as well one
totally.
day.
Like, listen, this is where the cheapest real estate is now. If only we could get there. Cool.
Like you can live there.
Yeah. Do you want to move on? I know that actually the next target that you're going to introduce is one of my favorite things to look at. And so
Ooh,
it hasn't been in the sky for a while, so I'm excited for that. So we want to move on to M13.
absolutely.
Okay.
Hercules globular cluster. Yeah, it's actually for me for M13 is the very first astrophotography I did with back like at the beginning when the observatory opened.
Oh, really? Wow. Okay,
So
cool.
it's the very first one that I was imaging. And I believe it was I can't remember. I think it was one of the RASC members that showed it's like the first time I was even learning how to use the observatory and how to do the how to use the softwares. And then the one that we were doing, or the person, I think it was at the time, I can't remember if it was Howard or Rask who was teaching me how to do it. And it was with the M13, the Hercules cluster.
Awesome.
So M13 Hercules, that's the one I always share with my students. It's like, this is the first one. This is my first astrophotography experience.
That's awesome. I think it's beautiful. I will share a story at the risk of
Right.
embarrassment, but it is real. I remember once I was practicing for one of the first live streams that we did. So I was at home and I was plugged into the observatory and I was kind of just playing with it on my own. And I got the Hercules cluster to show up on the screen. And I literally had an emotional moment. Like I got teary because it's just so beautiful and cool. The fact that we're looking at this cluster of stars all the way across the universe or the galaxy, and to have it pop up on the screen. So let's do that here now. So I'm going to switch our imaging mode. We were in what was called live view before, and so we were kind of getting a real time image. But now we're going to go to a stack. And what we're doing, you'll be familiar with this process if you've been here with us before, is that what we're doing is literally layering images together in order
She did
to
not
create.
know this was your favorite. I don't know. I would have thought, for some reason, I thought it would have been the Andromeda or Orion, because you had a story connected to your grandpa.
Yes, of the Andromeda Galaxy for sure. Yeah. So if I could say it's one of my favorites. I love the the way that it looks. Like it's just such an amazing object, like this big kind of beehive of stars in space. There we go.
Nice, nice. So so Hercules cluster, globular cluster. So it's quite far. It's about like 20,000 light years away, but it's also 145 light years in diameter. So you can imagine how big and vast it is. So if you know what a light year is 9.5 times 10 to the power 12 kilometers. So that's a very, very large number. And I know, like, because I've been trying to teach them try get my students to think about the concept of time and light and how vast what's 1 light year away. It's not an easy concept to grasp, I would say.
Yeah.
But and also with the nice thing about the globular cluster, they're very interesting targets to study because they are very, very, very old. They are almost close to the age of the universe because it took a lot of time for those cluster of stars to just to gravitate towards each other. And for that particular cluster that we're looking at right now, it's about 12 billion years in age. And our universe is estimated to be I think it's specifically 13.8 billion. So that's kind of quite close. Close. So they existed since the beginning of time, or since the Big Bang almost. And one of the coolest fact I learned recently is that the globular cluster, this particular one, was discovered by Edmund Halley. So he's the one who also discovered the Halley's Comet. So for me, my connection to astronomy is through a comet. That's how it started, like my enthusiasm with astronomy. Not Halley's Comet, but it started with a comet, and then from there I became fascinated with comets. But yeah, I thought it was very cool that particular cluster is discovered by Halley, and then Charles Messier came and he was the one who cataloged it because he was interested in comets as well. I like Charles Messier's stories. It's all about his goal
Chasing
was
comets
to
and trying to find stuff. Yeah.
And then he cataloged everything but comet almost. But I think he did manage to catalog some comets at the end. But I felt like it's funny at the beginning, like the majority of his targets were all non-comets.
Yeah, it's like all these things he found by not finding something. I feel like there's a story for life in there somewhere. It looks like our focus might be a bit off, and as a result of that, it's having trouble focusing and stacking our images together. So I'm just going to find a bright star and see if I can adjust our focus a little bit.
Go for it.
And go from there.
Well, talking about stars, so globular cluster, there's several or thousands of stars in there. And I think one of the things that's very cool to think about with globular cluster is that if there are life there, like because there's so many stars, there might be several solar systems. So if there would be a solar system within that cluster, one of the thoughts that was brought up is that will they have nighttime? Because there's so many stars out there, maybe they'll never even experience nighttime like we do.
Right.
Because they're probably just daytime. So I guess they would be like the north side, the North Pole or the South Pole where people live, where they live in 6 months of the year in daylight or nighttime. I guess that's how we can think about it. If we want to know what it's like to live in constant daylight, we just go there and experience it.
Let's see. Might need a brighter star. Yeah, I think there's actually studies done on what the level. Because I remember this was a debate among the team for a little while. It's like how bright it would be in a given globular cluster because of the proximity of all the stars and how like close together that they are. And And actually, we were talking about Arcturus earlier. Let's go over to Arcturus and focus in on that star for focus. And it would be like really bad light polluted city skies, like at nighttime, almost like all the time. It might be really hard to see. Like if you were a civil, you probably would have. We don't know if planets could even exist in globular clusters like that, but they might get pulled apart by the gravity as the stars are forming. But if a civilization did exist there, it might be really difficult for them to even know that there is like the rest of the galaxy out there. This is kind of interesting to think about. Okay.
Yeah, for sure. I guess if they were to look into if they were studying the universe, whatever civilization, if it exists, they would have, I guess, they would have to use technology to see what's out there.
Yeah.
But they wouldn't really see the nighttime that we do, I suppose. And it's interesting when you talk about because with globular cluster, there's several stars. So because of how old they are, you would think that there would be mainly they would mainly be like red supergiants, potentially neutron stars and black holes. But there are blue stars in there. I don't know if you ever noticed in the globular clusters, you do spot blue stars. And that got me wondering, is that why, if it's meant to be very old, like they're close to the age of the universe, why would we spot blue stars? Because blue stars are considered
usually
young stars.
Yeah, good point.
And I think one of the theories that I was reading out there is that because there's so many stars and because they're gravitating towards each other, there might be stellar collisions. And maybe the reason why the blue stars exist in globular cluster is due to stellar collisions.
So, and basically they're creating a new star, essentially, right? Essentially creating almost like a new star, right, from the collision of the older stars. I wonder if you get like a refresh of all that material that's inside of them, which is pretty amazing.
Yeah, so that's also like an interesting theory.
So if people have been watching on the screen as to what I'm doing here, we're focused on a star right now called Arcturus. Arcturus is in a constellation called Bootes, and it is one of the closest red giant stars to us. And since we're on this star right now, Zena, I know that you've been talking about how with your class, because you are a teacher, how you were talking about stellar life cycles with your class. So do you want to chat with that a little bit, and why does a star become a red giant? How does that happen?
Sure. Nice. That's awesome. Yeah, it's actually recently I just tested them on this. So we just finished the astronomy unit, and one of the things they get tested on is the life cycle of stars. So all stars they come from a stellar nebula. So fortunately we couldn't show a stellar nebula. We may not be able to show a stellar nebula today, but all stars, they originate from a star. We can call it a star-forming nebula, and usually the nebula, we know that when we look at nebulas, we know it's a star-forming nebula. It's usually from the color and the shape. So usually with stellar nebula, they don't have a particular shape. Like some nebulas, they're round, but with stellar is more, it just doesn't have a particular shape. And it has the red color that indicates there's a lot of hydrogen in there, because all stars start fusing hydrogen. From a stellar nebula, it has two paths. It could produce two types of star. One would be a very, very massive star, and that would be the blue star, a main sequence blue star. Or it could be not as massive, and that would be a star like our sun. So our sun is not that massive. So let's take the path where we're forming a star like our sun, which is not considered very massive. So when the sun starts with fusing hydrogen, and then when you fuse hydrogen, you go to the next element, which is helium, and that's what happens in stars. In the heart of stars, you have fusions that to produce heavier elements along the way, and with low mass stars or not as massive stars like our sun, it goes all the way to carbon, and once that happens, our sun will go through what's called a planetary nebula. I think like a planetary nebula example maybe people have seen in the past if they visited the observatory would be the Ring Nebula. So for those of you out there, if you've seen what a Ring Nebula looks like, it's round, it has the color blue. So one day our sun will go through that phase. It will shed all its light. So if there's civilization out there looking towards us, maybe, actually no, never mind. No, it wouldn't be like they will have to be in the future. But let's just say in the future, in the very, very far future, and there's civilization looking our way, maybe they will see they'll see the planetary nebula of our coming from our sun
Yeah,
or
and
from our star.
I've got a picture that we've taken of the Ring Nebula up right now, Zena, as an example.
Perfect. Yes, yes, so perfect. So one day our sun will go through that. We'll go through, we'll have, so we wouldn't be able to see it. So that's kind of one of the things that kind of disappointing is like we can't actually be, like if we are inside the nebula, we don't actually get to experience the nebula. It's more like you have to be far, far away and you're looking into another star that shows the nebula, that shows the gases that's spreading out into space. But we can't actually live in the nebula or see or experience it if you're in there. So yeah, anyways, going back to the planetary nebula. So our sun will go through a planetary nebula phase, and then once it sheds all its gases, so the hydrogen and all the way till carbon, you're actually left what's called a carbon core. So you're only left with the core of the star, and that's carbon, because that's what we said. For low mass like our star, it just goes to carbon, and it will have that fancy name called a white dwarf. Or you can or you can just call it a diamond in the sky, because the chains of carbon is just diamond. So you can think of it, or a poetic way of thinking about it is like our sun is destined to be a diamond in the universe, or a diamond in the sky. So I find that very cool.
Yeah, and I'm looking at this is one of the pictures we've taken right now of the Dumbbell Nebula, and I believe where I'm circling the mouse arrow right now is the white dwarf star that's at the center of that nebula. So another very colorful planet.
I actually forgot to mention that because we were talking about Arcturus. So
Yeah.
sorry, before becoming a white dwarf, it's actually going to become a red giant. So so our sun first will become a red giant. So a red giant is, we know that a star is categorized as red giant is when it's when it completes fusing hydrogen and then it starts with helium. So if the star is now when it's fusing helium or going through nuclear fusion of helium, then it turns into a red giant. So the idea is that the more it gets into the heavy elements, the star becomes less stable, and then closer to the end of that evolution of the star. So yeah, sorry. So our sun will become a red giant, and then red giant turns into a white dwarf.
And we have so at the H.R. McMillan Space Center, we have a movie we're playing right now called The Sun, and it talks about stellar evolution, and it ends with the sun consuming planet Earth, and then it just ends. That's the end of the movie. And I always think that's really funny because it's like such a terrible note to leave off on, because the people afterwards are like, so does that mean the Earth will be consumed by the sun when it enters red giant phase? So is that what's going to happen, Zena? I feel like then in that case we're experiencing that nebula firsthand as it eats us.
Yeah, technically. I actually tell the students that because when we talk about the concept of light and how it takes time for the light to get here, so with the sun, it takes 8 minutes for its light to get to Earth. And so I joke with the student is that if our sun turns the red giant, we'll find out after 8 minutes. But then we might have been already, engulfed by the red giant. We might never know.
Yeah.
That we were already like taken up or being inside the red giant.
Yeah.
Because usually when it turns into a red giant or red supergiant, the star will like it looks like it's getting bigger. It's pulsating.
Sure.
So it kind of like it gets bigger and smaller. That's why it kind of also increases in brightness, or even if that kind of makes sense. So if you're like maybe out there, not. Maybe you're on a space station far away from, maybe if you're on Mars or Jupiter and another planet, somehow we managed to do that, you might be able to see this. You might be able to see like this Earth being engulfed by the sun. Or sorry, not the sun. It will be like the red giant sun.
Yeah,
whatever we want to call it.
But I do tell the kids, like when people ask this question, like this process takes place over a really long time. So first, of course, the sun's not going to run out of fuel for billions of years, and even then, its evolution into red giant phase still takes like thousands and thousands and thousands of years. So just telling them, like, we're not going anywhere anytime soon. You don't have to mark it on the calendar. There you go.
Actually, very cool that you said it was a documentary.
Yeah, it's a film right now that we're playing there called The Sun, and it just talks about the life cycles of stars. But anyways, the reason why we had come here, and people might have seen me doing this, is that I brought up one of the control interfaces for the telescope, and this actually changes the focus. So there is a motor in the primary mirror, or attached to the primary mirror of the telescope, that it moves it in micrometers. So we're talking very, 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 very small increments. And but I'm kind of doing this by eye. And I think I might have improved the quality. There was a question in the chat who people had noticed that the Hercules cluster looked a bit fuzzy. That could have been atmospheric conditions, or it may have just been the focus was out. So I'm hoping that this has helped the focus. And so why don't we go back to M13 and see if we can get a better view of it this time.
Yeah, let's do that. And that looks amazing. Even that star, that looks good. Like the focus looks good.
Yeah, we'll see. So
Maybe we
this will help.
can. Maybe there was a cloud that passed by.
It's
Who knows?
possible, yeah. So the thing with the computer is that in order for it to layer the images together to create what we call a stack, it's basically sandwiching data over and over and over again on top of each other. In order to do that, the computer needs to be able to make out stars in the image. And if the stars aren't clear enough, the computer doesn't know where to layer the images on top of one another. So let's see what happens. And I'm going to change the system so that it is exposing each image for, I think, about 20 seconds or so. Let's see what happens. Oh yeah, I think that's looking a bit better. Let's see if it's going to be able to stack. Although the stacking time right now is really low. Or the time is low. I got to change that.
Yeah, maybe it's just sometimes when it's really it's nice to have clear, warm weathers, but clear is nice, but then warm weather is not necessarily the best weather for astrophotography or visualizing, because you get that effect if it's you would have that atmosphere disturbance.
Yeah.
Of our images. That's why they say the winter astrophotography is the best, where you have the air is crisp. And not because when the light travels through our atmosphere, it doesn't scatter as much.
Right. Yeah. You have that more steady air. Unfortunately, here, as we know, in the winter, we hardly get any sky at all, which is the problem.
I know. We don't live in the right part of the world.
No.
We don't get the good end of the deal, like in Chile. They have the best night skies.
That's exact. So already I'm seeing a lot brighter, clearer image. So I'm wondering if we were looking through a bit of cloud earlier. And we're stacking. Look, this is a good thing. So if you look down here where my mouse is, it now says frame stacked 2, which means that we now have a total exposure of over 40 seconds, about 20 seconds per frame. So that means we should be able to get a better view of the cluster this time.
I don't know. It looks like it definitely looks way better than the first time you attempt it. So yeah, maybe we will see it.
Still not quite as sharp as I'd want, but we're definitely getting more of the picture here. I'll zoom back a little bit.
Yeah, it looks good. And it's kind of interesting. I guess you can't really see the blue star, but when you do, when you're doing the astrophotography and you stack all these images and then you do the
well, if I adjust the
editing, which is that's the main thing, is the editing.
Yeah.
Not even the image capture, is the editing that takes the longest time.
If I adjust our color balance again, we should start actually being able to see some of the bluer stars in here. So we are starting to see them a little bit.
Yeah. And you can see with the globular cluster, most of the stars are clearly red giant, the older stars. So red giant, red supergiant, yellow stars potentially. And sometime then you will spot the blue ones as well.
So yeah, definitely seeing way more stars in here. Not quite as sharp as I'd hoped, but definitely better than before. And look at this. That's astonishing. We're talking the Hercules cluster might have a few 100,000 stars inside of it. One of the largest clusters that we can see of this kind in the Northern Hemisphere. There is one, the largest one is in the Southern Hemisphere that we can see. It's called Omega Centauri, but we can't see it from here. And the other possibility is that objects like that might be the cores left over of dwarf galaxies that have been consumed. But it's possible clusters like this are also made from collisions with other galaxies that churn the gas around in the galaxy and create these huge regions of star formation that never leave each other. It's imagined to think it's almost like a mini galaxy orbiting around the disk of the main galaxy. And we've actually sent signals to this one. We've sent a signal to this cluster that was sent by the Arecibo array, which has collapsed now, unfortunately, but it won't reach for 30,000 years. So if anyone replies, we're not going to We're not going to know for a long time.
Well, it's gonna be. You just have to put it in the will for your great 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 grandkids.
Yeah, great, 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 great. But
Like
yeah,
how many generation would that be? Depending.
oh,
Just put it. Just make sure you always tell the next generation to put it in the will.
somewhere in the will, yeah. Um,
Or you just have to keep maybe cloning yourself. Do what? Just keep maybe cloning your body so that you could keep reborn in the next
oh,
generation.
that sounds like an interesting sci-fi story. That one, I like this idea.
You know, right?
Um,
I mean, they exist out there.
yeah,
I don't know. It's the freezing. I know some people were
yeah, like
talking about like freezing their
cryostasis
brains
or
or
whatever.
body.
Yeah, yeah, totally. But there are some advantages if a civilization were to, again, we don't know if something can actually evolve. If
Hmm.
life can evolve in a place like this, it's possible that when protoplanetary disks form, that eventually planets emerge from. They're very, we're talking about loose particles of dust and gas, and if they are perturbed by the gravity of a nearby star system, they might not ever form. So we may not actually have solar systems in clusters like this. We're not sure. However, if say someone were to get here, say some super advanced civilization can make it all the way to a globular cluster, it might be an ideal place to set up shop because if there are planets, they are maybe light weeks or light days apart from each other rather than light years apart from each other. So it might be easier to have to communicate with one another, to send information between the bases that have been set up within the cluster, and maybe from there you start beaming messages back down toward the disk of the galaxy. Who knows? But we do know that other galaxies do have globular clusters like these. How many does the Milky Way have in total? I think 150. I'm thinking off the top of my head.
Maybe. That sounds about right. But that's actually such a cool concept. I actually haven't thought about that there would be communities of solar systems out there. Potentially. Like they would
Inside of
be all
globular
like
clusters, yeah,
with
that'd
each
be fun.
other, all these civilization, they would connect. So it's like oh, going back to sci-fi. It's like all the things we dream about.
Yeah, wouldn't that be neat? Oh, look I looked it up. Around 150. Look at that. I earned my science pay for the
Yeah, you
week.
got it right
I did.
from the top of your head. You got the right number.
I did.
You're
Speaking of
cool.
galaxies as a whole, do we want to take a look at a galaxy now? Try one of those out.
Sure. If
All right.
people are already fascinated, enjoyed looking at our globular cluster, then we could move to what galaxy? What
Would help
we
us
have
with the
actually
time.
several. We have a few galaxies on the list. How about we go into Cigar?
Yeah, let's do it. Okay, let's move on to the
Let's try
Cigar
Cigar.
Galaxy.
Of course, we're not promoting smoking here. It just
Nope.
happens that it looks like a cigar,
Which,
literally.
which is true of the naming of many things that we see in the sky. They're just kind of named after what they look like. They're like, that looks like a
Like
cigar.
this one is impressive. Like cigar looks like a cigar
Yeah,
actually.
that looks like a horse head, that sort of thing. All right, so let's clear the stack.
Bubble. What's the other? Oh, like a swan.
Or a swan, yeah, yeah, exactly. Or like this nebula looks like North America. Let's call it the North America Nebula. All right, let's see what we got.
Actually, one of the funniest one I've seen, like in terms of names, and it's the running chicken nebula, but it's not in our. It's on the southern hemisphere.
Oh,
And I
okay,
look
yeah.
at it like, oh, you have to really like, orient yourself to see what's like, where's the chicken? And Timmy's like, oh, these are the legs. Okay, and this is the beak. Like, wow.
And yeah, and you know what? I don't think I've been on the like near the equator, but not actually like ever in like deep into the southern hemisphere, like Australia or whatever. So I've never actually
Mhm.
really gazed up at a southern hemisphere sky, and I would love to. I think it would be kind of neat to look up and see a completely different sky. And that's still like we are still in the same part of the galaxy. We're just looking out in a different direction. But it's interesting to think that, if you did go back in time, for example, say to the time of the dinosaurs, when you looked up in the sky, there would have been a completely different set of stars. And the closest we could kind of come to that is if you traveled to a different hemisphere you've never looked at the sky from before.
Oh yeah, absolutely. This is actually one of the other thing I find very mind-blowing about as just studying astronomy is the concept of time. Like, because
Mm-hmm.
everything when we talk about how far away an object is, we're talking about in light years. And then when you think, what's a light year in kilometers? Like we've mentioned before,
Like
it's like
10 trillion or something.
9.5 times trillion,
Yeah.
9.5 trillion kilometer one light year. And then we're talking about like maybe for this one, or like what was the one we were talking about before? Like if we were just giving a number, just like if something is 200 light years away, you just multiply it by the light years.
Mm-hmm.
And just gives you a very, very, very large number with many zeros.
Not as useful to use anymore. Yeah, absolutely.
Not at all. And like I was mentioning, like it's that concept of light year, or like how vast that number is and why we have to use light year. It's not an easy concept to
Right.
like to grasp. And yeah, so and also like the other part to it is that it's so that means everything whenever we look into the night sky, we're looking at it happening in the past. So if we're looking at a star, say a blue star, we might be looking at the ghost of that star.
Right.
So the star might have already switched into the next phase. So for blue stars, because they are very hot and massive, so they would go into red supergiant. So maybe they've already turned to red supergiant. It's just the light hasn't got to where we are yet.
Yeah, and that is certainly true of these galaxies we're seeing, right? So like a galaxy like the Cigar galaxy, this is like millions of light years away. And so we are looking at this object in the past, like the history of the cosmos. I've always found that like so amazing. Cigar galaxy is 12 million light years away. So we're looking at like relic light, the history of time and space when we look through telescopes. That's why if anyone's noticed, if you've been to the Trottier Observatory, on the power, or one of the, I think the power module that runs there's a big box on the wall and it has the power that runs to the dome, but there's a TARDIS on there from Doctor Who. So if anyone watches Doctor Who, that's my TARDIS. Mm-hmm. And I stuck it in there because telescopes are kind of like time machines, as much as they are space exploration machines. If you know Doctor Who, it's about a time traveler. So, and the TARDIS is like this blue foam box that he travels around in. Yeah. They travel around in.
Yeah. It's like, it's your way to the past, or telescopes are just like you said, it's like a time machine, but it's more to the past.
Mm-hmm. So what do we know about this galaxy, Zena?
Other than that, it looks like a cigar. And for this galaxy, it's actually when we talk about different types of galaxy, I know that's something people are interested in. So I know if Edwin Hubble, so he was the Edwin Hubble. He studied galaxies, and like that was one of his interests. And one of the things he looked at is categorizing the different types of galaxies. And it turns out, so there's like when we talk about galaxy evolution, so there are the spiral ones, like our Milky Way,
mm-hmm.
and then there's also the irregular ones, where those are the youngest. Where they irregular, the term is like they just don't have a specific shape. And the older one, or one of the oldest one, they're elliptical, so they're just round. And the age of the galaxies, like simply, they're just categorized by it's not by necessarily the shape like Edwin Hubble thought. So Edwin was categorizing them by shapes. But it turns out you categorize them by the number of the type of stars exist in the galaxy.
Mm-hmm.
So if the galaxy has more of the older stars, then it's considered an older galaxy.
Right.
And if it has more of the younger one, like the blue one, then it's considered a younger galaxy. But then with Cigar is interesting because Cigar is an edge-on galaxy. So we don't see it from top view. So I find that it's one of those, how can you tell what type of galaxy it is? Whether it's clearly it won't be based on the colors. When I see it's probably not a young galaxy. So it could be either a spiral or an elliptical based off just the color, because it has more of the yellow stars or red giants. But we also know that Cigar has a black hole in the center. And it's been theorized for quite some time that every galaxy in the universe would have a black hole in their center. But I think nowadays there are galaxies out there that doesn't have a black hole, which is interesting. Which makes me think that what are they? Because usually every galaxy would rotate around a specific center. Yeah. What other things I could tell you about the Cigar galaxy?
My understanding is that this is it's like very luminous. So this galaxy is like 5 times more luminous than the Milky Way, and a center that's like almost 100 times more luminous. And that's partly because this is a starburst galaxy, so it's creating stars at a much faster rate than our galaxy. And my understanding is that one of the reasons why that might be the case is because it's interacting gravitationally with its neighbor, which we will try to see in a second, which is the Bode's
Oh,
galaxy.
yes.
And because
It is
they're tugging on
merging.
each other. Yeah, they're tugging on each other, and that's stirring up the gases, causing them to fall in toward the center, which might be creating bursts of X-rays, from the center of the galaxy, as well as radio bursts and the starburst activity. So usually a starburst galaxy is creating stars at a much higher rate than the Milky Way. That's why we call them starburst galaxies, and this is one of them. Which, by the way, and so there's a note here too, we were looking at this galaxy with our new fangled-angled eyepiece that we have right now at the Trottier Observatory. And basically, it is like a night vision camera eyepiece. And my understanding is that it's like military grade, but we've repurposed it for science and exploration. And so what you can do is if you come up and visit us on one of our Starry Nights in person, again, any other clear Friday besides the last Friday of the month where we do virtual, you can now look through this eyepiece, and what it's doing, it is not a digital eyepiece. This is an analog device, and it is taking the photons from space, it's amplifying them, and when you look through it, you're going to see that kind of green night vision view that you sometimes get in movies or video games, but we're going to be looking at stuff in space, and one of them that we looked at was this, and yes, the periscope was fixed. Someone asked online. The periscope is fixed now. We attached that eyepiece to the telescope, and we have these incredible, cool, enhanced views of the universe through that eyepiece. And so we were looking at this galaxy. You can see the structure of it with your eyes, no problem. Normally galaxies will kind of look almost like just a smoky haze to your eye, but it enhances the structure. We looked at the Orion Nebula, which we're not seeing as much these days because it does setting usually earlier in the night, but we're able to see so much extra structure in it. So this is a cool extra feature now that you can look forward to when you're coming to visit us for Starry Nights. Did you get a chance to look through it too, Zena?
Oh, well, my story is that I think I was the very first one who looked through it.
Cool.
But not the one we bought. It was there was someone who like a regular visitor to the observatory who actually introduced the monocular, that night vision monocular. And I went back, when we were I think when we were doing the line and I was a floater.
Yes.
So when I was floating, I think I don't know if I'm allowed to mention his name, so I'm not going to mention his name just because I haven't asked for his permission. So the person approached me and he had that monocular and I looked through it. I was like, wow, this is so mind-blowing. You can actually see you can see so much more. Like you can see, I think through it, we saw the Orion Nebula just from that monocular, not like, and it wasn't even it wasn't even set on a telescope. So that's what I was so mind blown by it, how the details you can see, like you can actually see a nebula through it. And then after that, I kind of told Joanna and our staff if we could buy this kind of this type of monocular, that night vision goggle. And yeah, I think Kieran is the one who looked into it, one of our staff members. He actually did the research. He was mind blown by it, and then we ended up getting it. So I want to say that I had the privilege to be the first one to experience this.
Yeah, which is awesome.
At least in our among our staff.
Yes. Yeah, I know, totally. Question in the chat was, how do you turn on the night vision, and can you guys turn it on for live stream? Well, for live stream, we don't need to do it because we have a camera that we're already looking through right now that is basically giving us a view that way better than our eyes would anyway. So that is for your eye to be looking into, which is why it's physically on the telescope. And so when you're there, you get a view that's somewhere between what you would get with your eyes and then say what we could get with the camera. So basically it's turning your eyeball into the camera in a sense is what you're kind of getting. But it's cool because you're still looking through the telescope. And so I feel like it gives more of that sense of intimacy because you're with the universe, because you're connected to the telescope physically and looking through it at that time. Maybe we should try another galaxy.
Have you seen it? I can't remember. Have you seen through it?
Yeah, no, I did. It was amazing. Yeah, it was really, really cool. I was looking at the Orion Nebula through it, and it blew my brain. I couldn't believe you could see so much structure in the object that we were looking at. It made it almost look three-dimensional. Cool. It was wild. It was one of the coolest things I've ever done. Here. Yeah, I think they're in the chat.
I think the person who, I wasn't sure. I think the person who actually did introduce it is here on our chat. But yeah. I don't see the actual name, so I'm not sure. I'm just still not gonna mention his name, but he can introduce himself.
Yeah, if he wants to, yeah, for sure. Okay, so we're
Yeah.
gonna check out the neighboring galaxy to the Cigar, which is actually not just neighboring in the sky, but neighboring in space, and that is called Bode's
Yeah, the
galaxy.
one is gonna merge with it one day.
One day they will merge. So you can actually see how close together they are. So here is right now on the view here. So here is the
And
Cigar galaxy that we were just looking at on the screen, and right next to it is Bode's galaxy. So that's where we're going to go to next, and hopefully we can find it. Bode's is not as bright as Cigar, so it might not be as good. But let's give it a try. This is one of my favorite galaxies. It is beautiful, and so I'm hoping it'll show up well enough for us. But we'll see what happens.
yeah, and I think unlike the Cigar, it's not super edge on, so you can see some shape to it, to the
Yes,
galaxy.
yeah, and
I believe.
I know we've done some more in-depth processing, like longer exposure time on the galaxy. So if it doesn't show up, I will at least find one of the images that we've done of it. And I am honest. I have tried to do Bodes, and I couldn't get it to turn out. Somebody did, because it's in there, and I'm jealous of it because it is a beautiful, beautiful image. So already right now, I don't know if I'm seeing anything here. It doesn't
No,
look
I'm
like
not
it.
seeing anything either, but
Also looks
I
like I'm
trust your
picking up.
skills.
Yeah, we might be picking up some glow I'm seeing in the image. That could be some light pollution from something on campus in this direction. I think we are looking over some of the campus buildings, so we might be getting a little bit of
So I
glow.
don't know, Joanna on the chat saying that we weren't quite pointed at it. Do you want to just double check,
Yeah, I saw that. I
Gaiax?
don't know if that is accurate or not because I did look for Bodes in here, but let's move the telescope over a little bit and see if that makes a difference.
Speaking of like merging galaxies, ours Milky Way will merge one day with our neighbor galaxy, the closest galaxy to us. That is Andromeda.
Yeah, and you know, we were talking about like not the most creative names in astronomy. Yeah, Joanna was right. We weren't on target. So yeah, we did find the galaxy. Let's do some more exposure time. But right now, the future name of that galaxy is Milkdromeda. That's a terrible name. I feel like we have 4 billion
Yeah.
years to come up with a
Oh my
better name
God,
than
no way.
that.
Milkdromeda.
Milkdromeda. That's terrible. That's a terrible name. There it is. Look, we see it. Okay, let's get some more exposure time on it, and maybe it'll actually show up. I'm excited. I'm excited.
It's insane. The Andromeda is only 2.5 million light years away, and
Only.
that's our closest galaxy.
I know, right?
2.5 million. Again, just going into like trying to get the concept of time, oh, how far away things are in space to my students has not been the easiest.
Yeah, it's astonishing, like the distances, even like in our local neighboring galaxy. Um, you know, and I often get, you know, sincere question from especially youth that I get to work with, and they often ask, when, when can we get someone to another galaxy? And trying to even just think about the fact that we can't even get to a neighboring star. Never mind, like a
For a
neighboring
planet,
galaxy.
like
Uh,
or at least to the end of the solar system.
yeah, even that's really hard. Like we've just gotten something into interstellar space, and even at the speed of our fastest spaceships, we're not going to get to a neighboring star for tens of thousands of years. Never mind another galaxy. This is why telescopes are so important. Most of what we know about the universe does come from studying with telescopes, and so I the better the telescopes we create, the more we learn about the universe, and the more that we learn about ourselves, at the same time. So a little bit about Bode's galaxy. There has been some supernovas detected in this galaxy as well. It does look like there is a supermassive black hole in the center that is larger than the one or more massive than the black hole in our galaxy, and it's possible that there is actually a secondary supermassive black hole as well, that they're kind of orbiting one another in the center. That could be as a result of galactic mergers. So when galaxies merge, the central massive black holes will kind of find each other in that mess of gravity and get closer and closer together. And like we were saying, that there is that interaction between this and the neighboring Cigar galaxy. And basically what we could actually track, I'll see if I can get a little bit more structure in this galaxy now, is filaments of
Yeah.
hydrogen. There's like these hydrogen highways essentially that are flowing between all of these galaxies. So they're already beginning to share material with each other, and that might be true of Earth and Andromeda, or Milky Way and Andromeda as well. So yeah, we're getting some of the spiral in here. We are seeing some of the dust lanes and the spiral arms. You can see the central core of the galaxy, but this is getting washed out by a little bit of the light pollution. This kind of purpley coloring I've seen before, and I think it is some of the LED lighting on campus that we're seeing here. But let's see.
I think so. Yeah, I was just trying to think, what is that like? What is this thing shining or like on our target? So that's what I was thinking too.
Yeah, so
Gives it a nice like glow, but it's not the glow we want.
yeah, so yeah, I
But
think
as an artistic, it gives it this artistic glow.
it does. Yeah, we are getting a little bit washed out, so you can see some of the structure here a little bit, but yeah, this galaxy has been washed out. But it is one of my favorite galaxies. So we'll give this a few more seconds here, and then maybe we'll switch to an image that was taken and processed. We can show you instead. All these galaxies are part of a bigger cluster of galaxies that we belong to. One of them is called the Local Group, and that contains the Milky Way as well. And then those are part of another larger cluster of galaxies called the Virgo supercluster. So we have some neighboring galaxies that all kind of are our neighbors in space, although, again, not any place that we'd get to anytime soon.
Actually, it looks pretty good. Like how you're trying to get rid of the glow. That's amazing.
Yeah. It doesn't look like we're going to get much better than that. Okay, so what we're going to do, I know that we do have a picture of this galaxy that has been processed. And so here is Bode's galaxy. Look at that picture. Isn't that amazing? What an incredible image. So if zooming in on the galaxy, we can see different coloring. The center of galaxies, like ours, so this is the core of the galaxy, those colors actually tell us something about the age of the galaxy. So, or the age of that region of the galaxy. So the cores of galaxies, they kind of form from the inside out. And so we're seeing those older stars in the center. Like you said, Xena, when stars evolve into red giants, they change in color. We're going to see more red, more orange, and that central region of the galaxy, just like ours, tends to be redder in color. And then we get these dust lanes. These are the spiral arms of the galaxy. Those dark lanes of dust are the raw material that stars are made from. So it's typically along those arms, like we see here, we get these sort of like magenta colored areas, and those where no stars are being born along the spiral arms of the galaxy.
All the stellar nebulas.
All those stellar nebulas, yeah, where stars are being made. And so
it's like our solar system. We're like on the edge.
Yeah, out toward the edge of the galaxy.
And it's interesting how just 100 years ago we thought we lived. Was it 100 years ago that we thought we lived? We were the center. We were in the center, and it turns out we were only on the edge.
Yeah, that might be the case. I know that it was around 100 years ago that we first realized that Andromeda was another galaxy. Up until that point, I believe 1926 is when this debate was solved as to whether or not, it was called the Great Debate, as to whether or not the Milky Way was the entire universe. So it's amazing to think that that only even 100 years ago that we only knew officially of one galaxy, and now there are.
And we thought our universe. We thought the Milky Way is the universe.
That's it. Yeah. That was it, and that everything we saw in space might be a part of our own galaxy. And now we know we've been able to map at least 10 million other galaxies through space. We have several telescopes that are mapping them right now. And there could be as many as 2 trillion galaxies in the observable universe, which is...
and that was only within the last 100 years.
Yeah, that's it. Yeah,
that's what I'm so mind-blowing about this. It's like we're having all these discoveries just within the last 100 years.
Yeah, and
it all took just to find it all took Andromeda. We just had to find out about Andromeda.
Yeah, and one of the people who gets a lot of credit for that is Edwin Hubble, whom the Hubble Space Telescope is named after. But a person who should also get some credit is Henrietta Swan Leavitt, and so I'll bring up a picture of her here. So this is Henrietta Swan, and Henrietta Swan Leavitt, she was the one who created the research that Edwin Hubble used to measure the distances to some of the first galaxies, including Bode's galaxy, the one that we're looking at right now. And so what she was able to do is realize that there are certain types of stars in space called Cepheid variables, and they can be used to measure distances across the universe. So at least to a certain distance away, certainly to the neighboring galaxies near us. And so Edwin Hubble, his calculations to the neighboring galaxies like Andromeda, to like the Bode's galaxy, was made possible by her research. And So in one of the past, we have May the 4th event coming up at the H.R. McMillan Space Center, and in one of the past events we did an event called "How Do We Know That Galaxies Even Are Far, Far Away?" And it was a story about Henrietta Swan and the importance of her research.
Nice.
So as much as Hubble
I
gets
like that
mentioned,
title.
yeah, we should know about her as well, because she was the one who made that research possible. One of the many women who are foundational to astronomy.
Yes, I like that we're giving them the appreciation they deserve,
Totally.
or the credit and acknowledgement. I need to mention her then for the next time I teach the space unit.
Yeah, absolutely. We had another galaxy on the list, and
Oh,
I
Joanna
think,
was just saying that she was deaf.
is that right?
I didn't know that.
I did not know that either. Okay, I think we wanted to also check out the Whirlpool galaxy. Do you want to do that one next?
Oh, another merging galaxy.
All right. Yeah, in this one we can actually.
Merging galaxies are quite common in the universe. I think that's also thinking about Edwin Hubble when he was categorizing or looking into the evolution of galaxies. It's how do you get the galaxies into their shapes? And they were thinking maybe it's because of the merging. So it could be the merging galaxy results into those different shapes at the end. So you start with your young galaxies made of the blue stars, and then the blue stars will die off to turn into the red supergiants. And then you get your merging galaxies or colliding galaxies to create that spiral, potentially. That's just a theory.
Yeah, and I know that we are learning more about galaxy formation all the time, especially right now the Webb telescope, which is looking to some of the earliest parts of the universe we've ever seen, and it looks like we're seeing galaxies with more structure than we expected. So that might help us learn more about how galaxies form. And of course, Dr. Joanna Wu, who is in the chat with us right now, her expertise is actually in galaxies and galaxy formation. And so she, feel free, Dr. Joanna Wu, to add anything to that in the conversation. And I'm excited because it looks like our view of Whirlpool might actually be pretty good. I'm already seeing some structure even within the first exposure.
Very nice. And the Whirlpool, unlike Andromeda, that's only 2.5 million light years away, the Whirlpool is it's about 23.5 million light years away. So it's way, way further. Definitely, it's nowhere near our neighbor. But there's you can actually clearly see the two galaxies up there. And so you have one that's your spiral, like our Milky Way. And I believe the second galaxy that's going to merge or cannibalize. I don't know if you heard of galaxy cannibalism. That's also a term out there.
They're eating each other? It's dreadful. It's dreadful.
I think it's the smaller one is also, it's like they call it a dwarf galaxy, but not sure what you would categorize it as. Would it be like an elliptical or another spiral, a smaller spiral? Actually, one of the things that, because I talk about galaxy merging, and one of the things, because I tell the students, oh, by the way, our galaxy is going to merge with Andromeda one day. And but not in the near future, but in the far, far, far away future. And they would ask, like, oh, what's gonna happen to Earth? It's like, are we gonna die? Are we gonna get destroyed? And I was like, I said it's unlikely because of how vast the space between stars. So it's unlikely that anything will happen to us. But the only cool thing is that if we experience the merging, like maybe the final merging of the two galaxies, our night skies would look different.
Oh yeah,
and I think
I'd see a whole.
I think there is an artist illustration of it. Like I think there was an image on the internet. He was just like it just illustrates as the galaxy's getting closer and closer how the night skies would change.
Cool.
I was like, oh, that would be a beautiful night sky if we are to experience it. But that wouldn't be us. It will be the great grandchildren. Almost like probably they're gonna evolve into something else other than humans.
Yeah, we may not even be humans anymore, right? Yeah. Although I think that is near the time when the sun is going to turn into a red giant, so we might just miss out on that. But yeah, it's incredible to think that two whole galaxies. Our galaxy might have as many as 300 billion stars. Andromeda might be upwards of 1 trillion stars. That two galaxies of that size can merge, and it's possible that not two stars will actually hit each other. So it's almost like, think of it more as like two clouds merging together rather than like a collision between solid objects. But here, yeah, we have like, look at this. This is really good. We can see so much structure in the spiral
For
arms
sure.
here.
That's amazing.
Yeah, that is really, really
Love
cool.
it. Like you can totally see the two galaxies, how they're merging. Like you can easily tell that one, like sometimes when I look at merging galaxies, sometimes it's hard to tell. It's like, are they in the same like dimensions or one is further than the other? But this one is clearly they are. That's amazing. And you have like the bigger one, the larger spiral one, and then you have the smaller one, the dwarf. I can't tell. What do you think the dwarf one? Do you think that's a spiral, another spiral, or do you think it's an elliptical
I
from the look at
I'm not actually sure on this one. I believe I don't know if at this point it would be considered an irregular galaxy because it's being torn apart by the others. So this might be a place for Dr. Joanna Wu to jump in. But
Yeah.
but yeah, the
Yes.
two are eventually going to collide with each other. It's possible that actually one of them might have already passed through the other galaxy and it's on its way back. So that's something else that can happen.
Yes, yes.
And we have seen structures.
Exactly.
Yeah, and we've seen structures in our own galaxy that is evident of collision as well. So, in fact, if you imagine like the Milky Way has a big disk, there is imagine like a handle that runs above that disk, almost like you could pick up the galaxy and carry it around, and it looks like that's a stream of stars that have been pulled out by collisions with other galaxies that have passed through perpendicular to the Milky Way and then like up and around again. So the companion galaxy to the Whirlpool galaxy is called M51 or Messier 51b, because otherwise the main galaxy is called M51. So it is considered to be a dwarf galaxy that's interacting with Whirlpool. And so and they are because they are close to us and because we can see them from this angle, they are some of the most researched galaxies when it comes to collisions, which is pretty cool. And one of the other neat things about this galaxy is that it has one of the few exoplanet candidates that is extragalactic outside of our own galaxy. And so it has not been confirmed, I don't believe yet, but there are a few planet candidates that now we have considered that we may have detected in other galaxies, and Whirlpool is one of them, which is pretty incredible that even from that distance away, there is exoplanet
Where would it be
candidates in
though?
there.
Would it be in the spiral or the smaller galaxy?
It
or
is-
they did that?
That is a good question. Yeah, the detection is in the larger galaxy, which is really cool. And the candidate was found using, and I believe this is how we've done this as well in other really distant galaxies, is that it's detected by the eclipsing of other X-ray sources with a massive star. So you create like this, like a transiting event with another star that allows us to have a momentary view into a particular solar system and determine whether or not something is there, which is really cool. If confirmed, it would be the first known instance of like an extragalactic planet. I believe there are some candidates as well in the Andromeda galaxy, but we're talking like millions of light years away. It is already difficult to find exoplanets in our own galaxy around stars,
Yeah.
never mind in another galaxy, so which is pretty incredible.
Still, it is all like yeah, it is incredible. It looks like we got photobombed by a satellite.
Oh, it looks like we
I don't know if you
did.
can see it.
Yeah, that.
And also, Dr. Joanna Wood did kind of answer my question. So she
great.
believes it's an elliptical galaxy, that smaller one.
Cool.
Which kind of just because of the color, which kind of makes sense. Elliptical are it's like the oldest type of galaxies because it has mainly the red giant, red supergiant, like the older stars. So it makes sense.
Yeah.
So you have like maybe it's an older galaxy that maybe the older galaxy needs to be, what do you call it? It would be like merging with another younger galaxy so that we can maintain, making more stars.
Burned out old galaxy.
Recycle things in the universe.
Yeah, which happens, right? Even just like you're saying in that in the globular cluster with the blue stragglers from the stars colliding with each other, which is really cool. And then, as we might have noticed here, there's a streak that's all of a sudden gone through the image. This is us being photobombed by another satellite. It actually happened in one of the previous images. This is actually an important part. So, an important point is that when it comes to astronomy, we are finding it more and more difficult to do research from the ground and even sometimes in space because of the extra traffic that is now in orbit around the planet. And if we look at like Starlink satellites, for example, not only are they bright in the visual spectrum, but there's now a second generation of Starlink satellites that are incredibly bright in radio, almost 30 times brighter in the radio spectra than they were the previous generation. So that our sky is now being polluted with our own artificial constellations, which is making it harder to do visual astronomy.
Yeah, it's like their numbers are getting higher and higher.
Yeah, we're launching more and more of them all the time. And unfortunately, our space law hasn't really caught up yet with our space technology. And so you can kind of just put whatever you want into space right now, and there's nothing really to stop you. So that is difficult because if we want to keep doing observational astronomy, we need clearer skies.
Space pollution. Just throw everything into space.
I know. Yeah. Okay, I think we were thinking about checking out a star cluster. And so the one that we were looking at was the double cluster. It might be a little low on the horizon, but let's give it a try.
Yeah, it's kind of tricky because we had like really nice targets, but they are not showing for us. I know like we wanted to look at the Crab Nebula, but that was not successful.
Yeah.
You can try the open cluster.
Yeah,
few weekends.
Maybe should have done this a little bit earlier in the night, but let's see what happens.
We can, or if not, we can show an image of like what it looks like, or even the crab. I know we wanted to take a look at the crab because we didn't show much of nebulas. Usually, we always like whenever we do Starry Night, we try to pick different objects, different celestial objects. So we go like a planet, or
I know we're still kind of out of nebula season is the problem. So as we get closer to the summer, we'll start having more of the nebula toward the center of the galaxy we can see, but we're not really seeing. We're kind of between winter and summer seasons.
The first time we couldn't show a nebula, I think.
Yeah, I think you're right, actually. Yeah.
Like we usually always have a nebula, at least one nebula to show. But I feel like, oh wow, this is the first time we're unable to show a nebula, so it's interesting.
No, the cluster's here, so we got it.
It's first time for everything.
Yeah.
Because remember, also, like, I'm trying to remember what's the first time experiences we had with the observatory. I remember, like, was it last year, I think, when we had Starry Night around Christmas time? And I was like, oh, wow, we haven't had, usually it's usually, like, it's raining around that time, around December, and we had that, I think it was the week before Christmas time, and we actually had a clear night. I don't know. Were you there? I'm not sure if you were signed up for that day.
I know that they all blend together. So many days under the stars up there, which is a good thing. That's a good thing. All right. Here we go.
Are we looking at? That's actually good.
That's quite good.
Bad.
Yeah, that's pretty good actually. So yeah, this is called the double cluster. It's actually two star clusters that are near each other. So we're looking at one of them up close right now. But this is an open cluster. So as kind of an opposite to the first star cluster that we were looking at, the Hercules cluster, which is ancient, really old stars, like you said, Zena, almost from like the beginning of time. This is much newer. So the age of this cluster is somewhere between 75 to 150 million years, which sounds like a long time, and it is for, life here on planet Earth and our time scales. But in the life of stars, it's not that much time. So the cluster is probably at least 20,000 solar masses, so 20,000 times the mass of our own sun. And they form the core of something called an OB association. So this is basically OB stars. If you think of stellar classification, stars have different letter grades depending on their surface temperature. And so the hottest of them are those big blue stars. They tend to be O and B stars. And so this cluster belongs to like a group of them, which is called an OB association. And this one is centered around the double cluster. And it actually has lent its name to our particular arm of the Milky, or one particular arm of the Milky Way galaxy. So our galaxy has spiral arms similar to the ones that we saw in the Whirlpool and in Bode's galaxy. And the arm of the galaxy that we're looking toward right now is called the Perseus arm. So this cluster, part of it belongs to what's called the Perseus-OB association. So it's a big association of young, hot blue stars and that are sort of part of that grouping of young hot stars. And there are 300 blue and white supergiant stars in this cluster, which is pretty amazing. So really, really hot stars that are a part of this cluster.
Yeah, so that's actually how you know they're considered young. It's considered like can you determine what an old cluster versus a young cluster? It's from the type of stars that exist. And with most of the open cluster, they are mostly blue. And that indicates that because blue are considered, like you said, they're young and very hot in temperature. So they're main sequence stars. And you don't see as many stars clustering together, but they are one day, eventually, they will turn into a globular cluster. But that's going to be billions and billions of years later in the future. Just realized I was looking at this and I got it. Sorry, I'm constantly thinking about.
No, go nuts.
As a teacher, you're thinking about like things like resources or how, like what I was thinking right now is that there's a question I could have put on a test because we're learning about blue shift and red shift.
Oh,
and
cool.
It just hit me that, I could have actually asked a question. I asked the student questions like, how do they know that the stars are gravitating towards each other? And it hit me. It was like the blue shift and red shift with them.
For sure.
So that's like with the globular cluster or the open cluster, it would be a blue shift. Because blue shift means the stars or the source of light is getting closer to you.
Yeah, and in this case, this cluster is
like
actually...
I don't know. This might be. It's just a thought I had in mind. I was like, oh my god, I could have actually asked a question like that on a test. That would have been a good one because I thought they're learning about Doppler effect.
Cool. Yeah.
Sorry, I didn't mean to interrupt you, but go ahead.
No,
that was just a thought I had to get out before I forget.
Yeah, and this cluster actually is headed toward us. So the cluster is traveling in our direction at 39 kilometers per second. So it's clipping along pretty good. Part of the star is moving around in the galaxy. And it's cool that we even know that at all. So there was a mission that's gone up into space called Gaia. And for the last couple of years, Gaia has been measuring the motion of stars, over 1 billion stars, the distance and the motion of those stars through the galaxy. And we know that because of the Doppler effect like you were talking about. So if an object is traveling toward us, the light from it looks a little bit more blue. Not that it is blue in color, but its light is shifted toward the blue part of the spectrum a little bit more because of it's moving toward us. And if you think of it like an ambulance in terms of sound, it's like when the sound comes toward you, you could tell even with your eyes closed if a vehicle like an ambulance or a car is coming toward you because it increases in pitch, right? It gets that, and if it's coming away from you, you get that of it going away. Well, light does the same thing, but in color. So an object moving toward you looks slightly more blue on the spectrum. If on the light spectrum, so even it could still be a red object, you're looking at it red, but it looks more blue than it would usually otherwise because it's moving toward you. Similarly, an object moving away from us is going to look more red. And so in that case, we can measure all those stars, and that's what's actually helped us map the shape of our galaxy is probes like this up in space looking at the motions of stars like these. And so I wonder, once this cluster sheds itself off into space, maybe in a few billion years around one of these new stars, there'll be some other civilization looking out into the universe. Wouldn't that be cool?
Yeah, and you know what? Another thought. Maybe we're already part of, maybe our solar system is already part of a cluster. We just don't know it yet.
And
unless you know it. Do we know it?
Well, there's a lot of open clusters like this. You can think of them as like birds leaving nests. So they're all kind of born together in a nebula. You can think of like that as the nest of stars. And in young open clusters like these, once the stars are born, they will eventually spread out through the galaxy and apart from each other. Because there's not, unlike say a globular cluster, they glob together because there are so many formed that they will hold the cluster together from their own mutual galaxy. But these clusters will be kind of mixed into the rest of the galaxy as it rotates. I believe that if I'm correct, I think it's probably over 10 years ago now, there was a star in our neighborhood that when it was measured was so chemically similar to the sun that it's possible that it is one of the sibling stars that was created in the original cluster of stars that the sun had formed in. I don't know if that was ever fully confirmed, but it was sort of a hypothesis that we did find a star similar enough to our own that it could have been within the same cluster that our star was born in.
And maybe they have civilization there too. If it's similar to our sun, it's possible.
Hey,
If
maybe,
we're all like
yeah.
originating from the same place, or like the stars, if we all came from that cluster, maybe it's possible
Yeah,
that they
like
have civilization
yeah, yeah.
there.
Like you were mentioning, those hot blue stars, they burn out really fast, but stars that are our size, they hang around for longer. It gives more time for life to evolve. And maybe like the red dwarf stars, which last the longest, maybe that gives that much more time for life to form. But we don't know, because those dwarf stars are also really tiny and the planets have to be
We're
really close to the
spreading out
stars.
where the distance is. We're all redshifted. Everything is being redshifted from where we are.
Yeah, eventually,
The distance is getting larger and larger.
yeah, and who
We're going to
knows?
be we're destined to be lonely and isolated in this universe.
Yeah, yeah, it is possible that if there's life in the Milky Way and, in a long time from now, they won't even know there's other galaxies out there. They won't be able to see them anymore. Okay, one other
yeah.
thing here. We were talking about nebula.
Sorry, go ahead.
You were talking about nebula. It is possible we might be able to see one. So let's see if we can find it. It is the Bubble Nebula, but it is kind of low on the horizon, but it's about the same altitude that this was. And so maybe it's possible we'll be able to see it. And then maybe we can squeeze this in as the last target. Let's see what happens.
Yeah, why not? And hopefully it's dark enough. I guess before, because now the day is getting longer. So it's still bright in the sky and the night sky. And I know, like, once we hit June, we don't really have real nighttime in June.
Yeah, that's right.
At least it's gonna be like, there's always gonna be that pitch of light out there.
We're still moving on that exposure, so let's restart. If we can't see it, I know we have a processed image of this nebula, so we can show it. Well, since we were talking about star formation, and this is a star that had been formed in a big cloud of gas. Yeah.
Stella Nursery, and you can tell, and it looks like a bubble.
Oh, I see a little bit in there. I see some stuff. We might be able to see something. Let's see. Let's get one more 20-second exposure, and then I'll play around with the light levels here and see what we got.
But yeah.
All right, let's see.
It might be hard to see, but I believe, you know what? I trust your skills.
Let's see what we got. Let's see. I can see.
I trust them more than mine.
I can see some nebulosity in there. Let's crank up the red a little bit. We can see some more in there. Yeah, there's something in here. Probably not as much as I'd hoped, but.
Yeah, you kind of see some, but the thing is, we know how it looks like. I'm not sure if the viewers if for the ones who haven't seen it before, it might be hard for them to know what they're looking at. But you're right, we do have a processed image of it.
Yeah. So I've zoomed in here on our app that controls where the telescope is pointing. This app, by the way, is called The Sky, which I think is aptly named. When we zoomed in here, this kind of gives us a kind of an idea of what we're looking at. And the square that you see here is actually the field of view of our telescope. So our telescope, this square here has been calibrated against the sky. So if we were to zoom in on something and we could see it properly, then that is kind of the field of view that we would see. So this is basically just like an example of what the image might look like in the field of view. Of course, it may not turn out like that exactly but that bright star that you were looking at is this one here. And there is some nebulosity kind of around it. You can see not quite as well as we'd want, but maybe I can pull it up a little bit more. If not, I'll cheat and I'll use one of our previously processed images here.
Yeah. So yeah, that's actually a good idea. Yeah, so that's nebula is about 7,000 light years away. So we're looking at it 7,000 years ago. I like that concept of time, how we're looking at it in the past.
I just think that's so cool. I think that's so cool.
And for constellation wise, actually, I don't know if you can see it and I know there's some object that we've shown today. We could actually see it with binoculars, like the globular cluster. You can see it with a binocular. Obviously, not on a clear night, potentially not polluted area, like light polluted. I don't know about this one. I don't think this one, probably not, seeing how far away it is.
I don't think so. Yeah, it's
You know
pretty
Orion,
far.
would you say, with the, I think,
Oh,
can we
totally.
see
Yeah.
Orion
With the
with
binoculars,
the
yeah, I
binocular?
think you can. Yeah, definitely. Unfortunately, beneath the horizon right now. Otherwise, that's one of our favorite nebula to look at because it's so bright. One of the closest star-forming regions to Earth. But you can start to see the edge of the bubble here. So after we've had
Yeah,
about
yeah, I
10 minutes
see
of
it.
exposure,
I see it.
and this hot central star right here is what's actually creating the bubble. So it is in a
Mm,
field of hydrogen gas. The gas is being kind of blown away by that hot central star, and
being excited.
being excited. Yeah, it's exciting the gas and pushing it outward.
All the hydrogen is being excited by the star in there. Yes.
And I believe that star is one of those blue giant stars as well.
Is it
Uh,
Alpha Centauri, maybe?
this is
Or
no, this one's much farther
one?
away because that's one of our neighboring stars. And so, as you said, this is like 7,000 light years away from planet Earth, so it's much farther away. But it is a one of these blue stars that is pushing that outside gas around itself away, and we see that happening when stars are passing through these gas clouds. It creates almost like a bow shock, just like a boat going through water and
Hmm.
pushing energy or the gas and material around it. I think that's about as good as we're going to get on this picture. So let's bring up one of the processed images.
We tried. I mean, we were really hoping for a nebula because, like I mentioned before, I think this is the very, very first time we haven't been able to show a nebula,
Yeah, which is
like
why they're
in
just so
like
colorful and
one of
fun.
our starry nights. So, like I said, it's the first time for everything. But it's good that we have like the process. We have images that we processed.
Yeah,
So yeah, why don't you show
I think
that?
the orientation was slightly different when we imaged the last time. So I think this one more time. There we go. So here are the images side by side, so you can kind of see what we were looking at. So on the left is kind of like we said, this is about a 5-minute exposure. The image on the right, you can see more of the structure in the bubble.
Off the screen. Can you put it more in the center? Because I'm looking at the
Oh,
screen. It
sorry. Yeah,
looks like
yeah,
it's
yeah. Here, I guess push it off to the left here a little bit more. And then it kind of gives you an idea of sort of what we're looking at. This might be a mirror flip to this one as well. So can I flip this horizontally? Well, let me do that in this one. Oh, maybe not. That's okay. Oh,
yeah,
can
that's
I?
beautiful.
Uh, can I do mirror flips on these ones? Is that what this one does? Oh, maybe it has to be this way. And then rotate it back. But I think you get the basic. There we go. Okay. Save. Okay, so here, oh, that didn't work. But you get the sort of the general idea. You can see this structure here is what this little peaky
Mhm.
point is right here. That's that central star that you're seeing right here. And so if we had a chance to sit here on this image in clearer skies and look at it for hours and hours and hours, then we would be able to get
Mhm.
more of that detail. Also, this picture, if I remember correctly, when Sarah, one of our past staff members, was editing or taking this image, I believe she also used a filter for light called hydrogen alpha. So that filters out a lot
Yeah.
of the other light that's coming from space, except for this hot hydrogen gas that's giving off kind of a reddish glow. And so that's captured by the camera as well and helps to accentuate that structure there in the nebula too.
Yes. Very, very beautiful. It brings
Yeah.
up that red color of the hydrogen. And you also have that blue star on the side. That's
Hmm.
very nice.
Yeah, one of those other like
I think,
really massive stars. I don't know if that's part of the nebula. It might be in the foreground. I don't actually know. That's a really good question. But yeah, you can definitely see the color differences there, alluding to one of those giant blue stars like you were talking about that don't last very long, burn out very quickly.
yeah. Okay, we're actually already past 11.
Yeah, I
So
know
that's
we're
actually a
over
good
here.
way to end it. Well, at least, okay, we couldn't really show a nebula, but we'll at least show one of the ones that we processed. So that's okay.
Yeah, and so thanks everyone for joining us again. Zena, thanks for joining from afar, and of course to everyone who is in the moderating group today. So to Zach and Malcolm, also to Dr. Joanna Wu for joining in as well, and for all of you as well. You know, we love doing this work. We love that people come and want to hang out with us, both online but also in person. A reminder that we gather together every Clear Friday. We post information about that on our social media, so you can find us on X or on Facebook. Our Facebook page at Trottier Observatory will post whether or not we're open. Usually we post sometime in the early afternoon, so like 1 or 2 p.m. Based on the weather, whether or not we'll be open on a given night. And we also have a mailing list. So you can also sign up on our mail list as well, and then you'll get an email blast from us as to whether or not we'll be open. So hopefully now that we're in the summer months, we'll have more consistent, better, clearer weather, so you could come and visit us. And also, like we were saying, check out that new cool infrared monocular that we have, and because we want to share that view with you as well.
Absolutely. Well, thank you so much, Matthew. Thank you to everybody else who joined us tonight. Thank you to the mothers and Dr. Joanna Wu for answering all the questions.
And we will see you on, hopefully, next Friday in person at SFU.